Hello, welcome back student. Today we are going to see the NDFA. In the last class we study about the NFA, okay, NFA or NDFA, but some of the examples today we are going to see. Before that we will see what we have done in the last class. So in the last class, we studied about the NDFA, non-deterministic finite automation, okay, and we took the examples. What are the examples? War, politics, sports and lottery, because we cannot determine what will be the answer. So the best example is lottery, because we don't know which number will be going to be a winner, okay, from the lottery. So non-deterministic automation. So here also the 5 tuple same as DFA, Q, sigma, delta, Q0 and F. Q is a finite set of state, sigma is a finite set of symbol called alphabet, okay. This is a finite set of state, and if you have a sigma 0 comma 1, this is a finite set of symbols, delta, and here the main important thing is Q cross sigma is 2 to the power of Q, okay. Hence the power set of Q, 2 to the power of Q, has been taken because in case of NDFA, from a state transition can occur to any combination of Q state, because of that it is a 2 power Q, okay. Q0 is a initial state, F is a final state, okay. So here we took some example last class. Q is equals to ABC. What is this? Finite set of state, and here the alphabet, finite set of symbols. Q is the initial state and final state, and we need to get the delta, and here the delta table is there. This is called transition table and this is called transition graph. So with the help of transition table we can make a transition graph. So in the last class we did this, and what is this called? This is called transition function. Okay, so we took another example in the last class. While seeing the table we created the transition function, and with the help of graph we make a transition function, okay. So in today's class we are going to see some of the examples. So this is like transition function, delta. What is the formula for doing the function? Present state, input symbol is a next state, okay. So let me delete these things, all the things, okay. Now fine. So here pen, now we will draw the transition function, okay. Now while seeing this we need to make a transition function. So what is the formula for the transition function? Is a current state, okay. What is, see, current state or present state, comma, input symbol is a current state or input state, okay. Current state, comma, input symbol is next state, okay. So we will see this and we will draw. First one, here Q0. What is Q0? Q0 is a initial state. Q0 comma Okay, present state or current state is CS. Q0 comma 0. Okay, what is the input? 0 0. So what will be the answer? Next state, what we are getting? We are getting is Q0 itself. Okay, now the next one is Q0 comma 1. We will go to 1. So what is the answer for this? What we are getting? If the Q0 is 1, so what we are getting? We are getting this one, Q0 comma Q1. Okay, now next one is Q1 comma 0. Okay, Q1 comma 0. What will be the answer? Here, as per the transition table, we are getting the Q2. Okay, fine. The next one is Q1 comma Q1 comma Q1 comma 1 is, what is the answer? What we are getting? Q2. Okay, now the next one is, and the last one, Q2 comma 0, input symbol is 0, and we are getting 5, means empty. Okay, in the same way, Q2 comma 1, what is the answer? As per this table is 5, empty. Okay, fine. So we design the transition function. First one, what is the present state? Why we are taking Q0? Because this is a initial state, Q0, then comma 0 is getting the answer Q0. What is this? This is a next state. Next state, if Q0 go to 0, then answer will get the Q0. If Q0 comma 1, then the answer will be maybe Q0 or Q1. More combination, you can get both. Okay, so in the same way, Q1 0, then Q1 1, Q2 0, Q2 1. Okay, so this is a transition function. Based on this, you can draw the transition graph. This is a transition table. So here we can draw transition graph. Okay, how to graph? First, take the Q. Here you need to remember this, capital Q, sigma, delta. Okay, here we need to write the delta. Okay, delta comma Q0 comma F. What is this? This is a phi tuple of. Now I will do one thing, I will change the color. I will change the color to, okay, fine, transition graph. Now we need to make. So what is a Q here? Q is Q0. What is Q? Q0 comma Q1 comma Q2. Okay, Q1, Q0, Q1 and Q2. So here I will like Q0, Q1, Q2. Okay, here this is a state. How many states we have? We have finite number of state 3. Okay, q0, q1, q2. Now here which one is the initial state? Is q0. Okay, this is a initial state. Now which one is a final state? q2 is a final state. We represent it. Okay, now what is a sigma? What is a sigma? 0 comma 1. Okay, 0 comma 1. So first, if q0 is 0, where it is going? It is going to itself, q0. Okay, okay. Now if q0 is going to 1, so it's going to q0 and q1. So here 0 comma 1, and this go to here and is get the value 1. Okay, so you can see this also, q0 0. If q0 is 0, where it is going? q0. Okay, q0 is 1, where it is going? q0 as well as q1. Now q1, this q1 is 0, where it is going? To q2. Click here, 0. If q1 is a 1, then where it is going? q2. So 0 comma 1. Okay, next, if q2 is 0, where it is going? Nothing. q2 is 1, then where it is going? Nothing. So empty means this is your final graph for the given table. Okay, so this is a simple way to make a NFA, while transition table, transition function and transition graph. Okay, fine. Now in next, here we will see this string can be accepted in this graph or not, we will see. Okay, for that first you need to make the graph. Okay, first you need to make graph. How many are there? P, Q, R, S. P, Q, R, S. Okay, this all are the states. Okay, now which one is the initial state? P is the initial state as per this table, and star S is nothing but this is a final state. Okay, now from P, if P is 0, where it is going? P as well as Q. So here if it is 0, is going to P, and here is going to Q. Okay, if P is 1 here, so where it is going? It is going to P. So here already we draw the 0, then just write the 1. Okay, next Q. Q is going to R when the label is 0, when the input is 0. Q is going to 1 when Q is going to R when the input is 1. So here 0 comma 1. Okay, now R. R is going to S. R is going to S when the input is 0. Okay, when input is 0, and R is going to 5 means empty, nothing, so no need to write that. Now S is going to S if it is 0, is 0. S is going to S when it is 1, so 0 comma 1. So this is a graph. Now we will see, with the help of this, with the transition function, we will see it is accepting or not. First What is the first one? Initial state is P, means current state or present state. P comma string 1 1 0 1 0. Okay, if 1 1 0 means this P and 1, then where it is going? If P is 1, where it is going? Is going to P only. Okay, what is our current next state? Is P. So this come here, and next step P comma and remove this, remove this one, because we gone there that state. So here P comma, what is the remaining? 1 0 1 0. What is the remaining? Is this 1 0 1 0. Okay, now what is the answer? P is 1. If P is 1, where it is going? Again it is going to P. Okay, this P go to the next. Okay, P comma, what is the remaining string is remaining? Remaining string is 0 0 1 0. Okay, what will be the next state? If P is 0, if P is 0, where it is going? Is going to P as well as Q. So where it is going? What we have answer? P comma Q. Okay, now here click, change the color. So now we need to remove this because P0 is finished. So go here. Now what is the remaining here? This one come here. Okay, so if it is coming here, so first you need to take the P0. Okay, so here wait, okay, so here we are getting the two outputs, like P, if it is 0, P if it is 0, then we are getting P and Q. You can select any one, so I am selecting the Q. Q comma, we are taking the remaining string 1 0. If 1 0, so if Q is 1, if Q is 1, where it is going? Is going to R. You can see the graph also, table as well as graph. Q is 1, it is going to R. Okay, so R is coming here, R comma, so here we need to change the color and remove this because we already visited here. So here now R comma 0. What is a 0? If R is 0, if R is 0, where it is going? Is going to S. Okay, now here S comma, is anything is there here? We finished this also, so we don't have any remaining string. So in place of that, you need to take the lambda or epsilon. Whenever you are getting this epsilon, you need to check whatever the answer is here, is it a final state or not? Yes, S is a final state, so accept the string. Okay, accept the string. S is a final state. Okay, so this is accept. Okay, accepted. So this is a procedure to solve the check the string is finite automata is accepting or not. Okay, so this is a thing. Already we did this in a DFA, almost the same, but the two outputs are there, because of that it is there. Okay, another string on the same problem. So you can take like present state is a initial state is p comma string 110110. Okay, so this is we need to check. Okay, here what will be the answer if p of 1 is p? Okay, now this p is coming here. So in the same way, p comma directly I am doing 10110. Okay, here what the answer we are getting? We are getting the p, or directly you can do like p comma 1, then we are getting the p, so the next also will be the p. Fine. The third one is p comma sorry, p comma 0 1 1 0. So what is the answer for this? P comma 0 is p comma q. Okay, directly I am doing. Now you can take any one, you can take p or q. So if I take again p here, the same thing will be I will get. So I will take the q 110. What is the answer for 110? Like q of 1, the answer is r in the graph. Okay, next r, you need to take r comma 10. If r is 1, where it is going? Sorry, r is 1 is not going anywhere. Okay, is not going anywhere. 5. So that is finish. So here if it is we are not getting, it is not accepting, so you can take like from here you can take p. Okay, like if you take p, one zero is, you need to take this step you need to repeat here 0 0 0 1 1, then you will get the output. What is output? Let's see. P0 is p comma q, then p comma 1 1 0. What is p comma 1? Is p p p. Okay, we will get p comma 10 is also a p, then p comma 0 is p comma 0 is p comma q. So what we are getting, this is not a final state, so this string is not accepting. Okay, clear? This is I shown you very fast. Okay, and this is simple way, already I explain you this. In the same way we need to solve this also. Okay, now the next one is the difference between NFA and DFA. This is very very important. The transition from a state is a single next state from each input symbol, hence it is called a DFA. What does it mean? Like if you want to go from here in the graph, here in DFA we will get like this, only one input at a time going right side. In NFA we will get like this 0 comma 1. Okay, the transition state of the state is to be a single next from each input symbol, hence it is a DFA. This same thing, it should be a multiple next state, here multiple, okay, multiple next state from each input symbol, hence it is called NFA. Fine. Empty string transition are not seen in DFA, but in NDFA permits empty string transition. So this is called empty string, but you cannot get in DFA. Backtracking is allowed in DFA, but in NDFA backtracking is not allowed. Means if you have any mistake, you can go back and you can continue the procedure. Require more space. It required very less space because of the first point. Okay, it need more space. A string is accepted by DFA if it transit to a final state. A string is accepted by NFA if at least one of the possible transition in a final state. Means we are getting two possibilities. From in this, any one of the state is reached to final, then it is a finite state accept. Okay. Now the next one is DFA will reject the string if it ends at other than accepting state. If all of the branch of NFA dies or the rejected the string, we can say that NFA rejected the string. Okay, now DFA can be considered as one machine. Okay, NFA can be considered as multiple little machine computing at the same time. Okay, so here take the example of ATM, here take the example of lottery or politician means voting. Okay, voting also. Now the eighth point is DFA is very difficult to design. NFA is easier to design. Okay, and here one more point I need to add here. Here all DFA is NFA, but all NFA, okay, all here, but I will remove this ATM. Here all DFA is NFA, but all NFA is not DFA. Okay, this is also a one point. All DFA is NFA, but all NFA is not DFA. Okay, eighth point is very difficult to design and it is easier to design. The transition function delta is q cross sigma is q, and here q cross sigma 2 to the power of q. So this is a today's class. We saw the DFA, NFA, and we saw some of the examples, and we saw the differentiate between DFA and NFA. Okay. Now thank you.